Hello friends, in this video tutorial, let us see how to use linear regression and regression trees methods of data mining using SSAS. So for the purpose of this tutorial, let us first of all go to our SSDT. Now let us create a new project. Let us name the project as SSAS Data Mining 4. Okay. Let us select this template, that is the one for data mining and multidimensional and data mining, right? Okay, so it has created a blank project. So let us add a data source. So data source is pointing to SSS data mining database, which is the correct one. So let's click next. Let us connect through service account. Click next, finish. Now let us add a data source view. Next, we'll add vTarget mail view. Let us call this as DSV, finish. Let us add a new data mining structure. Now let's go to next. So in this particular tutorial, we are interested in linear regression and regression trees. Now regression trees in SSAS are implemented through decision trees. Okay, so let us understand first of all what is linear regression. Okay, so let's go over here. So linear regression is generally a method of predicting future values based on a equation. So let's say if we are able to derive an equation of y equal to a is a constant, plus b into x, where x and y are both variables. So depending on the value of x, we can predict the value of y. So if we are able to come to such an equation, then we can use linear regression. In such cases, then we are using linear regression. And then what is a regression tree? Let's say if we are able to fit a single line of one such equation for all the data points, then it's a linear regression. But if the data points are forming multiple clusters, and for each of these clusters, or let's say group of data sets, then for each of these group of data sets, if we are able to fit a different line, let's say if we have 5 data sets and we come to 5 equations or for 5 lines which individually fit each of these data sets, then we call them as regression trees. Okay, so let us see how both of these concepts are implemented. So as I said that regression trees are implemented in SSAS using decision trees. So first of all, let us select decision trees. Let's click next. Next, vTarget mail will be our case or input table. Next, now the key will be customer key, which is correct, but in this case let us predict yearly income. Okay, this yearly income is a continuous value, it's not a discrete value. Okay, and let us predict this with the help of age, bike buying behavior, commute distance, education, occupation, gender, house owner flag, marital status, number of cars owned, number of children at home, region, and total children, right? So let us use these factors to predict our continuous value yearly income. Next, now age is continuous, bike buyer is discrete, number of cars owned, let us keep it as continuous, number of children at home is discrete, total children is also discrete, and this value we want to predict yearly income, which is continuous. So carefully observe that in this particular example we have got age as continuous, number of cars owned as continuous, and with the help of these two continuous factors and plus other discrete factors, we want to predict one continuous factor, which is yearly income. Okay, next let's keep 0 for the testing data, so we will use all the data. for our training data set. Next, let's call this as mining structure, and let's call this as LR, linear regression, or let's say regression trees. Okay, regression trees. Okay, so let's click finish. So we can see that our linear regression tree has been created. Now let's go to database. So this is our database. Okay, right now there is no database called SSAS data mining 4. Okay, and once we deploy our current solution, then a new database with this name SSAS data mining 4 will be created. Let's put it paste. Let's process this. Okay, so now let's go to database. Let's refresh. So now new database has been added, right? And it has got the mining structure of regression trees. Okay, so let's go back to SSDT. Now let's go to mining models. Now along with these regression trees, let us also add one more mining model, and that is linear regression. Okay, so linear regression has been added now. Now this is important. What it is telling is that linear regression mining model will support only these continuous values. It will not support these discrete columns. So it will ignore these discrete columns. Okay, so let us say yes. So we can see over here that age we have defined as continuous, so it is being supported, but all other discrete columns are ignored, whereas number of cars we have specified as continuous, so it is also supported. And what will be predicted? Yearly income will be predicted, which is continuous. Okay, so let's click save. Let's go and process again. Okay, so things have been processed. So let's go over here, let's refresh. So we can see that along with the regression trees, now linear regression model is also present. So now let's go and understand these models. So first of all, it is showing us regression trees. So it is similar to, the display is similar to decision trees, as it is a kind of decision tree. Okay, now what is happening over here is, see, this particular whole data set is following a function. It has applied a equation, one equation to this particular function data set, right? But now as it is bifurcating data into multiple subsets, see, every time it is trying to fit in a line or a equation to this particular data set. So over here if you go, then this is the first set of equation. Now this equation changes. Okay, if I further traverse any of the nodes, okay, then again it forms or tries to fit another equation to this particular node. Okay, if you go further and go over here, then it has again tried to form a new equation. Okay, so these equations are all different. So for every such data node or for every such set of data, it has tried to fit its own equation, which means it is trying to do linear regression for that particular data set. Okay, now that's why if we want to study any of if a particular node is of interest for us, let's say if a lot of data is lying in one particular node, let's say this node, then we can click this node and we can go through its equation, and based on this equation we can predict future values, right? So we can use this equation for this particular node. okay, and to do any further future forecasting of any of the yearly income values for the data member sets or the data members or cases which belong to this particular node or have data characteristics as per this particular node. So we can use this particular equation for predicting those values. Now, one important thing that I want you to observe is what is the equation for the whole set in case of regression trees. So let us note it down. Okay, so let us note it down. Whole data. Okay, so this is the equation, right? And now over here also we can come to know the dependency network as we have seen in earlier data mining techniques, right? Now let's go to linear regression. So we can see over here very important thing is this is trying to fit a single equation to all the data that is given to it as a training set. So which means it has formed a single data set. Okay, and in this data set it has tried to put in a equation. So we can use this equation for future predictions for this data set as a whole, right, with the help of linear regression. So let's copy this equation again and let's go to our notepad and let's see linear regression, and we can see that these two methods or these two equations are exactly the same. Okay, so this is how the tree has been formed, taking into consideration the base node or the root node as having all the data members, and in linear regression it considers all the data members as part of one node, right? So it has both has to give the same equation and both are giving the same equation. Okay, so with the help of such equations we can predict our future data values with the help of linear regression, or if it's a case of regression trees. Okay, so I hope friends this video tutorial on linear regression is useful to you. Thank you.